So here we have the function cot of 2x minus cosec of 2x divided by x. We need to determine its limiting value when x approaches 0. So when we substitute for the value of 0, so we have an indeterminate form of 0 over 0. So what we have to do, we have to simplify this given function. So let us begin. So we have limit x approaching 0. So cot of 2x can be written as the ratio of cosine of 2x over sine of 2x minus cosec 2x is the reciprocal of 1 sine 2x divided by x. Now we combine the two fractions in the numerator, so that will give us cos of 2x minus 1 divided by sine 2x, and we have an x in the denominator. Now we can take negative 1 as the common factor, so that will leave us with 1 minus cos of 2x in the numerator. Now this has been done because 1 minus cos 2x is equals to 2 times sine squared x. So we are going to replace this into the numerator of the given function. So that gives us 2 sine squared x over x times sine 2x. Now we're going to divide and multiply by x, so that we have negative 2 limit x tending to 0, we have sine squared x divided by x squared times sine 2x, and we multiply with another x to the numerator. Now arranging the limits, so we have limit x tending to 0, we have sine x over x times sine x over x, and we have x over sine 2x. Now we need a 2x in the numerator, so we are going to bring this 2 and multiply it to x, so that will give us 2x Now when we apply the limit to each of the functions individually, the first one, sin x over x, the limiting value will be 1, multiplied to the second function whose limiting value is also 1, and the final one, which is 2x over sine 2x, its limiting value is 1. So that gives us a limiting value of -1. So this is the value of the limiting value of the given function when x approaches 0. Let's do another one. So here we have a function given by tangent of 2x minus sine 2x divided by x cubed. We have to find its limiting value when x tends to 0. So let us begin by first rewriting the tangent function as the ratio of sine 2x over cosine of 2x. And we have minus sine 2x divided by x cubed, which will be equals to limit x tending to 0. So we take the LCM and then add the two fractions in the numerator. So we have sine 2x minus sine 2x times cosine of 2x divided by cosine of 2x, and we also have an x cubed in the denominator. Now we're going to take sine 2x as the common factor in the numerator. So we have sine 2x times 1 minus cosine of 2x divided by, we have cosine of 2x times x cubed. Now sine 2x over cosine of 2x, we will take it back to the tangent function. So we have tangent of x, tangent of 2x divided by x times 1 minus cosine of 2x will be 2 times sine squared x divided by x squared. So what we're going to do here, we're going to multiply the denominator of tangent of 2x over x by 2. And then multiply with a 2. So that will give us, we can rewrite the limit now as 4 times the limit x tending to 0. So we have tangent of 2x over 2x times sine x over x times sine x over x. So when we apply the limiting values to each of the functions, so tangent of 2x over 2x, the limiting value will be 1, and the limiting value of sine x over x is also going to be 1. So that gives us a limiting value of 4 for the given function when x approaches 0. Let us do another problem. So here we have to determine the limiting value of the given function when x approaches 0. So let us begin by first dividing the numerator and the denominator by x. So that will give us limit x tending to 0. So we have 3 times sine 2x over x plus 2x over x divided by 3x over x plus 2 times tangent of 3x over x. Now what we're going to do is we consider the first term in the numerator, and we are going to multiply the denominator by 2 and then multiply by 2. So that will give us 2x in the denominator, so we also have to multiply by 2 in the numerator. The x and x gets cancelled out, x and x gets cancelled out here. Now for the second term in the denominator, which is 2 tan 2x 3x over x, so we are going to multiply by 3 in the denominator, and also we have to multiply by 3 into the numerator. So that we have 6 times sine 2x over 2x plus 2 divided by 3 plus 6 times tan 2x over 3x. So we have to find the limiting value of this function when x tends to 0. Now when we apply the value of the limits to each of the terms, so the first term will be 6 times the limiting value of sine 2x over 2x, which is 1, plus 2 divided by 3 plus 6 times the limiting value of tan 3x over 3x, which is also 1. So that gives us a final value of 6 times 1 is 6, so 6 plus 2 will be 8, and 6 plus 3 is going to be 9. So this is going to be the limiting value of the given function when x approaches 0. Let us do another problem. So we need to determine the limiting value of the given function when x approaches 0. So here we are going to apply the identity that cosine of a minus cosine of b is equals to 2 times the sine of b plus a over 2 times sine b minus a over 2. So that will give us the limit x tending to 0. So we have the sine of b, which is 7x, added to a, which is thrice x, so we have 10x over 2, so that will be so this is sine, so we have 2 times sine 10x over 2 times sine 7x minus 3x will be 4x, so we have 4x over 2 divided by x squared. So we get limit x tending to 0, 2 times sine 10x over 2 will be 5x divided by x times sine 2x divided by x. Now we are going to multiply the denominator of sine 5x over x by 5, and we will multiply 5 to the entire function. Similarly, for sine 2x over x, we're going to multiply the denominator by 2 and multiply the entire function by 2. So that leaves us with 2 times 5 times 2 is going to be 20. So we have limit extending to 0 sine 5x over 5x times sine 2x over 2x. So when we apply the limiting value the limiting value of sine 5x over 5x is going to be 1, and the limiting value of sine 2x over 2x is also going to be 1. So we have the final value of 20. So this is going to be the limiting value of the function cosine of 3x minus cosine of 7x over x squared when x approaches 0. Let us do another one. So here we have to determine the limiting value of the given trigonometric function when x tends to 0. So let us begin by first writing as two components. What I mean by it is, like, we can write sine x squared divided by, so we have x raised to the power of 6 in the denominator, so we can break it down and write it as x squared times x raised to the power of 4 and 1 minus cos x squared. Now this is having the form 1 minus cos x equals 2 sine squared x squared 2 sine squared x over 2. So we have 1 minus cos x squared, so that will becomes 2 times sine squared x squared over 2 divided by x raised to the power of 4, which will be equals to limit x tending to 0. We have sine x squared over x squared, so this will be one of the limit, times 2 limit x tends to 0. So we break down sine squared into two terms, so we have sine x squared over 2 divided by x squared times sine x squared over 2 divided by x squared. Now we use the definition that limit x going to 0 sine x over x is equals to 1. So this particular limit is going to be 1. So we have 1 times 2 times limit x going to 0. So here what we're going to do is we are going to divide x squared by 2. So that means we have to multiply by half. Similarly, we're going to divide x squared by 2 and multiply by half. So that will give us this particular limit, which is sine x squared over 2 divided by x squared over 2 times limit x tends to 0. We have sine x squared over 2 divided by x squared over 2. So the half and half gets multiplied, and that gives us 1/4. So this by definition will be 1, the two of the limits. So we have finally 1 over 2. So this is going to be the limiting value of the given trigonometric function when x tends to 0. Let us do another problem. So here we have the trigonometric function x cos x plus 2 sin x over x squared plus 10x. So we have to determine its limiting value when x tends to 0. So let us begin by dividing the numerator and the denominator by x. So that will give us limit x tends to 0. So we have x cos x over x, so that will be simply sine of x plus 2 sin x over x whole divided by x squared over x will be simply x plus 10x over x. Now we apply the limits to each of the terms in the numerator as well as the denominator. So where limit x tends to 0, cosine of x plus 2 times the limit x going to 0 sin x over x divided by limit x tending to 0, we have x plus limit x tending to 0 10x over x. So that gives us cosine of 0 plus 2 times, so as per the definition of sin x over x, the limiting value is 1, divided by limit of x when x tends to 0 is simply 0, plus the limiting value of 10x over x is going to be 1. So cosine of 0 is 1, so we have 1 plus 2 divided by 1, so this gives us a limiting value of 3. So here we have another trigonometric function, 2x minus sin x over x plus 10x. We have to find its limiting value when x goes to 0. So we begin by dividing the numerator and the denominator by x. So that is going to give us 2x over x, which is going to be 2, minus sin x over x, divided by x over x, which is going to be 1, plus 10x over x. Now we can apply the limit to each of the terms and both the numerator and the denominator. So the limiting value of the first term in the numerator will be simply 2, because 2 is a constant, minus the limiting value of sin x over x is going to be 1, divided by the limiting value of 1, which is the first term in the denominator, is going to be 1, plus the limiting value of 10x over x is all going to be 1. So we have 1 over 2. So this is going to be the limiting value of the given function, trigonometric function, when x tends to 0. Let us do another problem. So we have the trigonometric function 5x times cos x plus 3 sin x divided by 3x squared plus 10x. So we have to find its limiting value. So we begin by dividing the numerator and the denominator by x. So that is going to give us limit x going to 0. We have 5x times cos x divided by x. So that is going to give us 5 cosine of x plus 3 sin x divided by x will be 3 sin x over x divided by 3x squared over x is going to give us simply 3x plus tangent of x over x, which will be equals to, now we are going to apply the limiting value to the limit to each of the terms. So we have 5 times cosine of 0 plus 3 times 1 divided by 3 times 0 plus 1, which is going to be 5 times 1. Cosine of 0 is equals to 1. So we have 5 plus 3 divided by 1, which is equals to 8. So this is going to be the limiting value of our function, trigonometric function, when x tends to infinity to 0.